So, being a Spark user group, we better say something about Spark, and are there any roles for Spark in improving the situation? Well, it'd be sad if I said there weren't really at this meeting, but yes, there are some. If you think about high-integrity systems alone, two things we want to show about the system. One, that it's functionally correct. Does the application do what it should do? Are there any unintended, undesirable behaviors? Can we ensure they're eliminated? And the other thing we want to really is show that the act of model compilation has produced something, an implementation, that is sound in some way. The former of those two is obviously how Spark has always been used. It derives annotations, the data flow, information flow. The second is a bit different because what we're talking about is the annotations that relate to the fundamental properties of the model, not the fundamental properties of the meta model might be better, rather than the actual application itself. So it's slightly different. So how would that work in practice? Structures are generated code based on sound structures, substructures. You capture all these in the architecture meta model. And you generate a set of fundamental annotations that reflect the properties. And then you analyze the model to show the generated code exhibits those properties. Actually, you don't quite do it that way. You generate the code, analyze the code, and infer that the model is correct. But if you end up with a model that isn't, well, if the analysis doesn't come out with the expected results, then clearly there's something wrong with the model or the translation process. Either way, you've got something to actually give you some confidence that what you've produced is either right or wrong. The other advantage of this is that you can start taking the expertise of all your specialists in Spark and actually capturing it in the models. If you can capture it in the models and then reuse it, you actually get the benefit of these people being used across many projects at once rather than being focused in on one project indefinitely and not being able to spread that expertise around very easily. I mean, the way in which you would approach this is effectively bring together all the different skills together to generate this architecture meta model. So you bring domain expertise, Spark expertise, modeling expertise, and runtime expertise all together to actually create the meta model that's appropriate for the application, well, for the class of applications you're thinking about. The other advantage here would be that, of course, if you're generating code with Spark, you've got the opportunity to start doing proof of absence of runtime errors in terms of automatically showing that the VCs generated for runtime errors that can be discharged by the simplifier. It's one of those things where you can actually get a big benefit from using Spark in these environments. It may require a few pre- and post conditions to be generated from the meta model, but that's not a big deal really if you get a good payback on it. As an example of this kind of approach, there's a paper, industrial presentation at ADA Europe this year by Eric Verdeen, who is actually here today if you want to talk to him about it, describing how you could generate such a Spark model compiler. The link actually takes you to the slides from that presentation. Actually, what this did was took UML and XTUML and generated Spark Ada from it. The tools used for the project were the Bridgepoint tools from Enter Graphics. So it has the advantage that the code generator is open. You can write your own code generate or your own model translation, your own model translators, and you can actually customize those however you want them. So effectively what happens is the meta model is captures the form of the application, picking on the experience of the Spark, Ada, application domain, model compilation experts. And it was done by a small team of specialists and only took it a man-year of cost, in effect, to develop. It took longer than that over time, but the actual overall effort was only one man-year. And what it produced was effectively code that was suitable for a SIL3 application. So this code actually could be used in a SIL3 application. There were a number of goals that were set. They were all achieved, but notable ones. Code efficiency was similar to that of a mature model compiler, non-Spark model compiler, and I think with more effort being spent on optimizing it, we could have produced better code. And for automated proof of absence of runtime errors, we had a goal of 90% of VCs automatically discharged by the simplifier. We achieved better than 95%. So that was a very positive outcome. And we got the usual Spark benefits. we find that system designers had introduced redundant requirements, which gave us flow errors. So we actually were able to improve the solution because we could see that there were problems in the starting requirement. And it also exposed some weaknesses in the XTUML semantics. So we had to make our decisions about what we thought those things meant in our environment. And we had to be very careful with that. The other advantage of this is, unlike other autocoding techniques I've seen where the source code that is generated is completely unintelligible, this actually generated code that was very, very easily understood. I mean, that's almost essential at this point, because if you want to try and understand why you've got a flow error, if you can't understand the code, there is no way of working out what it was caused by and how you might fix it. The important thing to note is we're not using the tool, we're not trying to generate Spark annotations effectively that the examiner will just accept as being good. We're trying to generate the annotations we think should come from this model, and if they're not good, you fix the model. You don't fix the code. You don't try and change the annotations. You actually go and fix the model. The model must be wrong if you fail on flow errors. So that's what we can do. What does the future hold? Well, I think this depends on what everybody wants, really, what the developer community wants. I think as a community, we have to be pretty clear about this. Software design is what I started talking about here. I don't see any reason why it's not as crucially important as it always was, but we seem to have lost some of it in this process. If we go to the MDA approach, we can certainly recover the software design. That's what the architecture meta model is. It's a way of encoding the software design. But we need open frameworks and open code generators to be able to do this. The idea of buying licenses and then buying maintenance on licenses isn't a way that's going to work with this. We need much more open technology and really working on a basis where, as a company, we understand our product domain, we understand our runtime platform, but the model, the tool vendors understand their tool, they understand what translation technology is possible. Working together in a kind of a more supportive environment would be a much better way of doing it, rather than buying a tool off the shelf and then trying to work out how you actually do it yourself and trying to use a one-size-fits-all code generation strategy, which is not necessarily particularly useful. I guess from my own point of view, I think that probably these kind of technologies can be very beneficial in the future, assuming we can get the right attitudes. The problem is if we don't, we're very dull indeed, and you'll end up in a place where, from a software engineering point of view, the design becomes an irrelevance, and it's very much a dark ages, if you like, of software engineering. Certainly, it is not a model-driven up. Well, autocoding will not be a silver bullet. It will be the emperor's new clothes, well and truly. So finally, the goal was to question the trend towards autocoding, and it's quite a mixed picture, really. The naive use of autocoding is there's some real issues. You'll get your code very quickly, but what code do you get? I can see the appeal to management and sales teams for being able to produce a demonstrator project really quickly, but I'm not convinced that autocoding gets you any more quickly towards your in-service state of a final product than the traditional approach does. I think it just changes the dynamics of the front end of the project a bit. Now, it's important you demonstrate things early and you get some customer confidence, but it should be seen in that light, not seen as the panacea for the whole project. If you use MDA properly, maybe you can do a bit better than that. And if you generate Spark Ada from MDA, you can certainly realize a lot. And this has been, we've seen this, and it's very impressive. Certainly you get faster development because that's what you're getting from autocoding and the MDA approach anyway. You get much easier V&V because you've actually got code that you can still understand, and you're getting static analysis and proof of absence of runtime errors for free. You get efficient code if you've so encoded the architecture meta model, but you will try and do it for your platform, get it right for your platform. And I guess if we want to look at it as a real benefit, you can actually reduce the cost of doing safety and security related applications. It only depends how much you think the cost of those applications relates to the software in its code rather than the actual other work that goes around them. You certainly reduce the software costs, but I'm not convinced you reduce all the actual certification costs and the safety case and things like that, other elements like that particularly. But you certainly get some benefits. Anyway, that's all I've got to say. So if there's any questions, thank you very much.